Our section 5.7, we're talking about inverse and radical functions. So an inverse function has got to be 1 to 1. And the notation for inverse function is f raised to negative 1 of x, this right here. So a function is an inverse function of f if f raised to negative 1 of y is x. Now notice between these two right here, where the x was, okay, now there is a y. Where the y was, now there's an x, so your domain and your range have flipped. Okay, now to check to see if you're given two functions and you're trying to see if those two functions are inverses of each other, we'll plug one into the other, and if you get an x value, if it equals x, then that's a check to see if they are inverses of each other. Okay, and you can plug the other one into the other function. You can do this both ways. Either one of them is fine, but you should get x as your final answer. And if you do, that means that they are inverses. If you do not get x, that means they are not inverses of each other. Okay, now note that we're used to x raised to negative 1. Hey, that is x, or 1 over x. Yeah, that's fine. But when we're talking about inverses, f raised to negative 1 of x, that does not mean 1 over f of x, okay? The f raised to negative 1, that's just a notation saying, hey, we're talking about an inverse function. And not all functions have inverses. So let's look at this one. We're going to find the inverse of 2 minus x. So the first thing I'm going to do is I'm going to change f of x to y. Then I'm going to change x and y, and then solve for y. So I'm going to add y to both sides, subtract x from both sides. So y equals 2 minus x. Okay, so those are the inverses of each other, and this one happens to come out to be the same exact thing. Now let's look at this one. So same thing. What we're going to do is we're going to change f of x to y. We're going to switch our x and y values, and then we're going to solve for y. So I'm going to multiply both sides by y plus 2. Okay, so then we have x times y plus 2x is equal to y, because these cancel out. And then I'm going to move 2x over. So we're going to have y is equal to y minus 2x. Divide. Well, not divide. Let's move y over to the other side. Now I'm going to factor out a y. Okay, now I'm going to divide x minus 1. So y is equal to negative 2x over x minus 1. And that will be your answer. Okay, so for this one, first thing we're going to do again is we're going to change f of x to y. Switch your x values and your y values. Now I'm going to multiply both sides by 5y plus 4. Cancels out here, and I have 5xy plus 4x is equal to 2y plus 3. I'm going to move that 4x over. So 5xy is equal to 2y plus 3 minus 4x. Going to move the 2y over just to get all my y's on one side, like I did the last problem. Factor out a y, and then divide by 5x minus 2. So y is equal to 3 minus 4x over 5x minus 2. And that would be my final answer. Let's look at this one right here. All right, so same thing. We're going to change f of x to y. And then what we're going to do is switch our y's and x values. And then we're going to solve for y. So to get rid of this cube root, I need to multiply this by 3 and do that by both sides. So these will cancel each other out and left with what's underneath that radical. So I have x cubed is equal to y minus 1. Add the 1. So y is equal to, and let me do this, you'll have x cubed plus 1 is equal to y. So y is equal to x cubed plus 1. And that will be my inverse of this function right here. Now we already said, how do you test to see if two functions are inverses of each other? Well, you plug one into the other, and if it comes out to be x, then hey, they are inverses of each other. If it does not come out to be x, then they are not inverses of each other. So let's look at this one. Determine if f of x and g of x are inverses of each other. So we'll do f of g of x. Okay, so wherever I see an x value in f, I'm going to plug in this whole thing. So negative 3x minus 5 over negative 3 plus 5. Okay, so we have a negative times a negative. That will be a positive, so they can cancel those out. Cancel the 3's out as well. And so I have x minus 5 plus 5. Those cancel, and I'm left with x. Okay, so I can say, yes, f of x and g of x are inverses of each other. And you could have done g of f of x. So you could have done negative 3x plus 5 minus 5 over negative 3. Okay, so you get negative 3x, because these go away, over negative 3. Those cancel out, and hey, I get just x. So yes, they are inverses of each other. So let's look at these two. So we'll do f of g of x. Okay, so we have the square root of 2 times 2x squared minus 7 plus 7. Okay, so I have 2x squared minus 14 plus 7. Okay, so now I have 4x squared, and then I have minus 28 plus 7, and then 4x squared, and then negative 28 plus 7, negative 21. Okay, doesn't look like I can do anything else with that. So since it did not come out to be x, these are not inverses of each other. Okay, so let's talk about the domain and range of an inverse function. So notice how we were talking about earlier between these two between these two right here, this one right here, and this one right here. Notice how where x is, now there's y. Notice where y is, now there's x. So they're flipped. So the domain and the range have flipped. They switched. Okay, so the range of the function f of x is the domain of the inverse function. The domain of the function is the range of the inverse function. So what you're saying is, if you have f of x and you have a domain and you have a range, and then if you have the inverse function, well then so we're right, domain and range. The range of the original function is now the domain. The domain of the original function is now the range. They completely switched over each other. So let's look at this. What is f of 9? And that's really saying that 9 is an x value. So I'm going to come here and look for 9 and then find my y value. So that's 5. Here, if f of x is equal to 6, so really f of x is really just y. So y is 6. So now I need to come over here to the second column and find a 6 and then grab my x. X is negative 2. Okay, now I have an inverse function. Okay, so everything is backwards. We're used to saying, well, okay, that's f of x, so that means x equals 1, but since it's an inverse function, it's not x, it's actually y is equal to 1. So I'm going to come over to y is equal to 1, and then I'm going to grab that negative 7. Okay, and then this right here, we're used to saying, okay, that's f of x equal to 5. That's really just saying y is equal to 5. But since it's the inverse function, it's not y. This is actually x is equal to 5. So when you come to x values, find our 5. Okay, and I'm going to grab that 8. Okay, so everything is switched when it's talking about the inverse function. Now let's look at the graphs of the function and their inverses. So sometimes you might have to restrict the domain, and the reason that you would want to do that is so that you will have a one-to-one function. And to test if something is a one-to-one function, you can use the horizontal line test right here. So when you have the original function, say right here, say this is the original function. When you go to graph the inverse of that function, what is it going to do? You're going to have this line right here. Y is equal to x. You're going to have that straight line, and it's going to flip over that line right there. So you'll have this inverse right here. Okay, so to find the inverse graphically, once you have your function plotted, you need to graph it or mirror it over, flip it over that y equals x function right there. And remember the horizontal line test we talked way back when. It's just used to determine if you have a one-to-one function, so you'll use the horizontal line test. So draw a horizontal line through the graph. If any horizontal line intersects the graph more than just once, then the graph does not represent a one-to-one function. Okay, so determine if the two functions in the graph below represent inverse functions. Okay, so say that this is one function right here, and here's the other function right here. Now this is the line y equals x, and they look like they are mirror images of each other. So yes, these are inverse functions. Now this one, we have one function right here, and then another function right over here. And then this is our y is equal to x. Now notice that y equal to x is cutting the picture here in half, is not a mirror function of each other. So these are not inverse functions. Okay, well, look at this one right here. Determine the inverse for the graph below. So I need to draw y is equal to x. And so whatever y is, x will be. So we should go through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and on up. I'm getting off just a little bit up there. Negative 1, negative 1, negative 2, negative 2. So let me fix this up here. Okay, and it goes through the origin. This is the origin right here. Okay, I need a mirror image. It starts at 5 right here. So I'm going to start at 5 right here, and it should do something like this. And this would be the graph of this original function here and its inverse, which is what we graphed as well.